Welcome to Chapter 2 in the AICE Chemistry lecture series. Today we're going to start Chapter 2, which is on electrons in the atom. We're going to go over Section 1 today, which is simple electronic structure. In the future videos, we'll cover Sections 2, which is evidence for electronic structure, Section 3, which is the subshells and atomic orbitals, Section 4, which is electronic configurations, Section 5, the periodic patterns of atomic and ionic radii, and finally, we're going to end with Section 6, which is patterns in ionization energies in the periodic table and their causes. So starting off with Section 1. Section 1, we're going to go over simple electronic structure. How are the electrons organized in the atom? Now, this should be very much a review of honors chemistry material, but with a few added things in there. We're going to start with the part of the quantum mechanical model that we went over last year in honors chemistry, which is the energy levels, sublevels, and orbitals. Starting with the highest of the three, which are the energy levels. Energy levels are where the electrons are placed within the electron cloud. The electron cloud is arranged by subdividing it by energy levels. Energy levels are often going to be represented with the symbol N. So N equals 1 being energy level 1, N equals 2 being energy level 2, so on and so forth. So we can see here N equals 1 will be energy level 1, N equals 2. So if we look at this graph right here, when we're looking at the ground state at the bottom of this, N equals 1 means that this line represents energy level 1. N equals 2 means that this line represents energy level 2, so on and so forth. Their number from 1 till, realistically speaking, there is no end, but practically speaking, only up to energy level 7 and 8. But they're numbered from the nucleus. That means that if this is the nucleus, the first energy level out from that nucleus is energy level 1. The second energy level from there is energy level 2. Third energy level from there is energy level 3, so on and so forth. So when we look at, these are two different types of models for the energy levels. The one on the left is a circular model where we represent the atom as a whole circle with the nucleus at the center and energy levels moving out from 1 and up as we move away from that center. Whereas the one on the right is a model where we essentially are only seeing a small part of this circle, and we represent the energy levels as lines, as horizontal lines. And so we will imagine the nucleus to be here at the bottom, and then the lines going out from their energy levels. So if we have the nucleus at the bottom, then the first line representing the first energy level is energy level 1, then farther out is energy level 2, farther on than that is energy level 3, so on and so forth. The farther away from the nucleus that these energy levels get, the less tightly the electrons are going to be held and the more energy they have. Now, I know that sounds contradictory, but it's not. The amount of energy an electron has versus the amount of how tightly it's being held are not necessarily the same thing. Electrons are held more tightly the closer they are to the nucleus. And that's very simple. It's basically because of magnetism. If we look at the magnetism in general, so let's put up a black screen here. If we have a positive mass, which is the nucleus in the center, the distance that two magnets or two charged particles are from each other is going to play a role in how tightly they are. So if we had an electron, we'll draw it here in blue, here, that electron is much closer in distance to the nucleus than an electron, let's say, here. Because energy levels are where the electrons are and their distance represents, or the higher the distance, the higher the energy level. If we have an electron here, let's call this energy level 1. If we have an electron energy level 1, it is much closer to the nucleus than an electron in energy level 2. Well, this distance difference is going to affect how attracted or how tightly held the electrons are to the nucleus. The outer electron, the one in energy level 2, let's make this a little better here. The electron in energy level 2 is going to be less tightly held than the electron in energy level 1, because there are more attraction since the electron is closer in energy level 1. So the more distance there is between the nucleus, which is positive, and the electrons, which are negative, the less tightly that electron is held. So an electron in energy level 1 is more tightly held, or it requires more energy to remove than an electron in energy level 2. And that is why we say an electron in energy level 1 is going to require more energy to remove, and we'll get to that later on when we're doing ionization energy. Now, when we say that the electrons in the outer energy levels, like energy level 2, has more energy, that is different than when we talk about how tightly held it is and how much energy it takes to remove it. We say an electron that is in energy level 2 has more energy for the same reason that we talk about gravity. So for example, if you were standing on the ground floor of a building, you have less gravitational energy than if you were on, let's say, the first floor. Or even if you were on the second floor. So gravitational energy is going to go up the farther up you go. And we can think of it as if you have to fall from the first floor, then you make a little splat. But if you fall from the second floor, you make a much bigger splat. And that's because you have much more gravitational energy. Oh, this is the second floor. You have more gravitational energy up here than you do on the first floor or even in the ground floor. So the gravitational energy is going to go up as we move away from the Earth, as we move away from the ground floor. And that's because there is more time or distance that gravity is pulling you down towards what essentially is ground zero, which is the gravitational or the ground floor. Well, it's the same thing with electrons. Because the electrons on the second floor have not gravity but magnetism pulling them towards the nucleus, the electrons in the second energy level have more energy than the electrons in the first energy level. And that's because of the same reason with gravity, because that pull has more, there's more pull towards or there's more distance towards that nucleus, meaning if they were to fall into the nucleus, because they're not going to, they would release more energy as they do so. And that's why we say they have more energy, but they're less tightly held. So that is very important to note the difference of those wordings, right? Because wording is everything in Cambridge. There's going to be a difference between the three things. How tightly held something is, how much energy it has, an electron has, and how much energy it takes to remove it. So if we look at these three, two of them agree, two, and then one of them disagrees. How tightly held something is, and how much energy it has are opposites. So how tightly held something is. Let me find the different color we haven't used yet. Go ahead and use this blue. No, I already used blue. Red. So how tightly held something is. The lower the energy level, the number, the more tightly held. Meaning as we go down, things are more tightly held. N equals 1 is more tightly held than N equals 2. N equals 3 is less tightly held than N equals 2. So the lower the energy level, the more tightly held the electron is. How much energy an electron has is the opposite. The higher the energy level, the more energy. So the higher the energy level number is, N equals 1, N equals 2, N equals 3, the more energy we'll have. So N equals 3 has more energy than N equals 2, N equals 2 has more energy than N equals 1. And then finally, how much energy it takes to remove it, that goes along with how tightly held it is. The higher and the energy level is, the less energy it takes. So it's very important that you understand this, not because necessarily you will need to explain it thoroughly, but because when you're asked a question, you need to know which of these three they're referring to. So there's a difference between the question, how tightly held is an electron, versus the question, how much energy an electron has, versus the question, how much energy it takes to remove it, to remove that electron. How tightly it's held and how much energy it takes to remove the electron, those go together. The lower the energy level, the more tightly it is held, and the more energy it will take. How much energy an electron has is the opposite. The higher the energy level, then the more energy that electron will have. All right, so let me go back to the PowerPoint. So again, the farther away from the nucleus they are, the less lightly they are held, but the more energy they have. And we can represent again those is as a circular diagram or as a horizontal line diagram. So, electrons in the shells. There is a limit to the number of electrons that an energy level or principal energy level, as the full name is, can hold. As we go up from the nucleus, the energy levels can hold more and more electrons. Energy level or energy shell number 1, and that is something that you need to start getting used to, the idea of that switching back between shell and level. Energy level, energy shell means the same thing. So, saying energy level, energy shell, or primary or principal, energy level. These are all the same thing. Oops. Oh. These are all the same thing. They're synonyms of each other. So make sure that you don't get confused by wording. You do need to start getting used to the idea that certain things in chemistry do have multiple names, even different names from Cambridge or like British speak in chemistry, or just like American English speech. So just know that these three, energy level, energy shell, principal energy shell level, or principal energy shell, those all mean the same thing. Now, as we move up in number for the energy level, the more electrons that energy level can hold. Energy level 1 can only hold 2 electrons. Energy level 2 can hold 8 electrons. Energy level 3 can hold 18 electrons. Energy level 4 can hold 32 electrons. And this is due to how those energy levels are filled in, which we'll go into later on because these energy levels can be further subdivided. We can use simple electronic structures to show how many electrons individual elements have in each shell. And that's what this is right here, this sulfur diagram. This is electronic structure diagram. It is also a lot of time called the Lewis dot diagram because it is very similar to a Lewis structure. But essentially what we have is the nucleus of the atom in the center with the energy levels going out from it. So at the center here we would have energy level 1. So this is n equals 1. Then the second ring that we see here is energy level 2. And then that third ring is, oh, no, it is blue. That third ring is energy level 3. So this diagram shows the individual energy levels, and then the X's represent electrons. So here we can see that energy level 1 has 2 electrons, energy level 2 has 8, and then energy level 3 has 1, 2, 3, 4, 5, 6 electrons. And that's in specifically sulfur, because sulfur has a total of, let me see if it's up here. I actually don't think I have sulfur on here, but sulfur has a total of 16 electrons. And we can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, all 16 electrons represented with their locations for the energy levels. Another way we can show this is by using in a comma notation like this one, where we just put the element's name and then with separated by commas the number of electrons each energy level has, moving from left to right from lowest to greatest. So the 2 here represents 2 electrons in energy level 1. The 8 represents 8 electrons in energy level 2. Oops, let me fix that. And then the 6 representing energy level 3. So this is basically saying that we have 2 electrons in energy level 1, 8 electrons in energy level 2, 6 electrons in energy level 3, for a total of 16 electrons. These are 2 ways that you can show this. You're not very likely to see or to be asked to do this version on the AICE exam, although it might show up. Again, it is in the curriculum, so it is fair game as far question. Most of the time, if you're asked to do this, you will be asked for this type of diagram. And here you can see just in general for the first, I believe this is the first 11 elements, hydrogen, helium, all the way to sodium. The atomic number, which for a neutral atom will be the same as the number of electrons, and then how many electrons each one of the energy levels have. So you can see until one energy level is full, we don't move up to the next one at first. That will change later on once we start learning about the sublevels. So here you can see one electron in the first energy level for hydrogen, 2 electrons in the first energy level for helium, and then once we have 3 electrons in total for lithium, that's when we then move up to energy level 2 and put 1 electron in there because the first energy level is full. So that is it for section 1. We'll keep looking at the subdivisions of the energy levels and where the electrons are located in the following sections in this chapter. Until then, I'll see you next time.